Next, we will have Dr. Antti Aronen from Glaston to talk about how to change the tempering process control from settings to specifications. And Antti will be telling us a lot about the automation part of it. Antti is a senior research engineer at Glaston, has been in the glass industry and in heat treatment processes for over 15 years, and main area of interest is in the modeling of the deformations and stresses in heat treatment processes. Antti, floor is yours.
Thank you, Mika. Welcome everyone. I see that still people are coming, so I think I can start now. So, welcome here. I will give you some ideas how we have solved this problem, how to make tempering easier, and so that even not that skilled operator can use it, and how we can otherwise also optimize the process to get more benefits from a tempering machine. And my goal is that show you what are these advances and how we can, with autopilot, minimize the operator's role in glass tempering. At first, one question that how many of you have tempering machine? Good, there are some people, good. Maybe you have faced some of these things during processing. One thing is that maybe you have seen that your machine doesn't work as well as it should. You are expecting a little bit better quality. Maybe in one shift you get good quality, in another shift not that good one. And you always want more capacity if you are running late with your production. Or another thing is that you are looking for a new operator, old one has been changed to another company, and then you are looking for new talented, new professionals who have already experience. But how about if he doesn't have to be so experienced? If he can be just some new one and still do good quality products with the tempering. Or you want to have good quality all the time. Your customers are waiting for good quality, and beforehand you have to have problems with the shifts that one shift is doing a good one, but another one doesn't do that good quality. So these are things what maybe you have been thinking that how we can solve this problem. So our idea was to do automation or increasing automation, do something with the process, and take this experience, knowledge from good experts and automate these things. So that we have been done in autopiloting to make everything easier based on knowledge what we have. And also combine experience, the knowledge, theory, and automation what's capable. If we are looking tempering process, here is one tempering line. If we are looking at first the heating part, here. So main things in the heating part are that you have to heat glass to around 630 degrees, 640 degrees, so that tempering is possible. But also at the same time, depending on glass thickness, you shouldn't go to too high temperature to improve your quality. And to make avoid different kind of optical defects and other things, you should keep this heating all the time symmetric over the glass thickness, so that glass is, when it's moving on rollers, it will stay on rollers, and that doesn't cause the problems in the overall tempering process. So basic things, quite simple. And same thing with the cooling. Couple things. You have to have suitable cooling rate so that you get the right stresses in the class what you want to temper or heat strengthen. So you can adjust the cooling pressure so that you get the right stresses. And same thing here, that the cooling needs to be symmetric so that you can get a good flat glass at the end. Kind of simple, but there are some problems. You don't always temper same size of glass, same clear glass. There might be different glass sizes, different coatings, paintings at the different areas of the glass. And that all makes tempering more complex. Or you want to maximize your performance, maximize your quality. If you can do one by one, very good quality all the time, but when you want to make lots of glasses in a short time, then you have to optimize this. And you have to know how your machine is really working, how you should do this operation, what kind of settings you need to use. If we are looking, here's one screenshot from a normal Glaston tempering machine user interface. There are several different parameters for heating, convection, for cooling. It might be a little bit complex. Someone can think it is really complex. And they don't even know what they should set to get a better quality, even they have been working with the machine for a long time. So we wanted to make this one easier. And that's why we know from the experience and from theoretical aspects that how tempering machines should work and how we can change the settings so that we get better quality. And that's why we made this autopilot. And kind of autopilot does this everything for you. You just have to say that what kind of thickness, what thickness glass you have, what kind of coatings you have, what's the main result, what you want to get. Do you want to get the tempered glass, heat strength glass, something else, and also give some ideas about that about things what we can't measure with the devices with what we have in tempering machine. So if you know that you have a batch edge quality, if there are some holes, if there are some cutouts, they give information about that, and it will do at some point some advances for that one. And it makes recipe automatically so that you always get good quality from your machine. So we think that this automation simplifies the processing so that you don't have to know that much that what kind of settings you use. You just have to know what you want to temper or heat strengthen, and what is your target. What do you want to do it tempered or maybe at some point set that you want to do 100 megapascal instead of 90 megapascal, and then you can machine will keep settings for that by itself. But to do this all things so that we can better understand that how settings should be defined, we need more information from the process. We need to monitor this whole process to get this automation to work. We have been collecting data from tempering machine from different points. I would say that there are tens of different measurement points in the furnace and chiller together. It measures what are temperatures, what is environmental condition in the process or around the process, and those affect to a result what you get from the tempering process. So with the information what we get the furnace state and environmental condition, all the measurements, we can do everything better. We can give this all information to AI, and then we get also definitions about what you want to do, and those all together we can make a good settings so that we can get better quality out there from our tempering process. And also then we can measure what was the end result. We can measure what's the flatness. We can measure other things, anisotropy, white haze, and see that what was at the end the quality. And that way we could see that, okay, there happens something, quality is not good. We can look from all the other measurement points to see that if there was something going on in the machine which causes these problems in the end quality. And then maybe compensate some values, or we can say that, okay, you need to maintenance in your machine to get it to work as it should. So with the monitoring, we can optimize these things. We can optimize the process. We get more information about whole process, how it works, how well it works, if that machine is in a good condition or not, if there are some things what needs to be compensated. And that way we can improve your machine and the end quality in your processing. We can also, with all this monitoring, we can get settings from different machines. We can compare how different machines are working, and that makes then easier to gain information from different machines, so that if one customer has problems with a new product, new coating, maybe we could help them so that we are looking how it has been done with the other machine, and get the information what we can change from one machine to another machine. Because there are always some differences between machines. It might be that it's installed at a different the distance from the sea level, which affects the cooling part. There might be a little bit small settings. There might be that there's some measurement points are a little bit different places, and the sizes can be different in machines. So there are different things which can be taken in consider with this kind of machine DNA, what we call it, so that you can better transfer information between machines. So in that case, the idea is that when we think about quality, we want to make optimal quality. What is it you can define. But there is also some kind of range where you want to stay. And if we have this machine DNA, we can start here from the good quality, and with this whole autopilot system, we can stay really close to optimal quality, so that we can all the time get the good end products. And with this autopiloting, you can always use the same tempering rules between operators, because operators, they have their own mind, they want to put own settings there, but with this one, it doesn't allow these operators to do so much different settings in the process. One way good, one way not that good. If you are thinking from the operator side, they want to be head of the machine and want to do everything perfectly like they are used to do, but they have also good days and bad days. So if we can always do same kind of quality, independent of what are you in a morning shift or a night shift, that makes your processing much easier. So we find that this autopilot and monitoring of this process, you can get better and better quality so that we can take those changes in consider and compensate in the process parameters if needed. And as a conclusion, I'm coming to same point as in the beginning, that the autopilot minimizes the operator's role in a glass tempering on a typical products. So mainly for rectangular shaped glasses with the clear glass, coated glass, those are relatively simple to make. You don't have to change that much parameters, but you have to know from experience how it works. But if you don't have that experience, then autopilot helps for that, and also for all the experienced operators, they don't have to think so much that how it looks like. They don't have to know what is the furnace state. It automatically is taken in consider. And then experienced operators, they can focus their time on the complex cases. New coatings are coming all the time, and new shapes are coming all the time. So it still needs operators, but this simple work can be done with the autopilot, and then operators can focus more on the things which are more complex or new things where there is no autopilot that doesn't work yet. Thank you.